Seem to have lost some phone. Anyway, I can watch the rest of it on YouTube. So what I'm going to do for the rest of the class today is to basically go through some examples. Look at in the last example we looked at here, we looked at taking in user input of a string, and we looked at how do we calculate the length of a string, or how do we work out the length of a string. I'm going to go through some of the other commands that we had looked at, from the notes, and we'll work our way up to doing something where we have to process to a string, where we have to go and we have to evaluate everything on a particular string. So that's question one there. I can get rid of that. Okay, so for the second question, what we're going to do is we are going to create a program that takes a string in from the user. Stewart, no, the user, and prints just the first character. So what this is going to do is it's going to replicate what we had previously. We have our scanner. We're going to have to enter in a string. We're going to take in the string, and then what we're going to do is we're going to have here car C. And we'll say that is equal to s dot car at 0. So it's going to get the very first character in that string. And I'm then going to print out C. Okay, so the new bits in that piece of code are what I've highlighted there. We are going to create a character variable, so char, and you can see that appears in blue. It's a lowercase letter, so we know it's primitive, or it's lowercase, begins with a lowercase letter, so we know it's a primitive data type. And we are going to take the first character at index 0 out of our string, and we are going to put it into character C. We can actually then change that. Let's change it again. We don't need to declare C because it's already been declared. But we can say here s.length -1. So what the second line there, what line 14 is going to do is get me the character at the end of the string. So the length of the string, remember, is going to turn back how many characters we have. But because we start counting our index from 0, length -1 will give us the last character within that string, whatever size string it may be. The first one we hard code as 0 because that's the way programming will structure it, that your first element will always be 0. But because we don't know how large the string is going to be, we need to use our s.length to tell us how many characters in total we have. And then we subtract 1 away because we don't count, while s.length or string.length is going to count how many characters. So the first character will be counted as I have 1 character, then 2, then 3, then 4. Our indexing goes from 0, so I'm subtracting 1 away there. So if I go to my command prompt and I go Java C strings 2, and add in strings 2 here, and get me to enter in a string, and increase the font of that actually slightly. So I will enter in Carol again. And if I press enter, it tells me that the first character is capital E and the last character is L. Okay, and so the way we did that, we used our char at command, which returns back to character at, and we give it a numerical reference for our index. And what's going to happen here is it's going to say, actually, do you know what? Let's do this. Let's animate it for you so you can see what's happening. The -1 is because if we just did string.length or s.length, it tells me how many characters in total are in there. But remember, our index starts from 0. So that means that if I say, if I go back to my code here, sorry, get rid of that. I go back to my code here and I get rid of the -1. Save it. Run it again. Run it. Enter in my string. It breaks the program. And the reason for that is it's trying to access index number 12 because there are 12 characters in that string. However, we start our index counting from 0. So the highest index is 11. That's why the -1 is in there. If you ever want to find the last character in a string, it'll always be length -1, no matter what string it is or how large that or how small that string is. Okay, so I'm going to take this code. Actually, do you know what? I'm going to do this. I'm going to go to jelly it. So we've seen jelly before. This is the way I'm going to animate my code. And I'm going to get rid of the user input because it doesn't look as neat as when we run it through the command prompt. I'll leave that in there. I will create that font larger so you can see it. Well, 36 is not bad. Let's see. Yeah, 36 is what it is, because if I do 72, you'll see one line of code and that's all. Okay, so here is the program that we have. If I compile that, hopefully we don't get any errors. Okay, so what's going to happen now is it's going to go off. It's going to create those variables. So you can see here we have there. I think I have that pinned. So you can see it's putting Owen Carroll and string S up here. It's now creating character C. So you can see this is the line we're at here, and it needs to figure out what that is. So the way we figure that out is it'll go and get character Owen, or sorry, string Owen Carroll character at index 0. And so it's going to figure out what that is. So it goes off to the string, it takes in the string and the character, and it will calculate, well, what's at index 0, which is going to be the letter E, the first character in our string. And that gets returned back, so it gets put into variable C. And then we got to print that. So the weird creepy hand gets it. Okay, next line. We're going to do the same command, however, rather than giving it a fixed number, we're going to say calculate the length of our string, subtract 1 away from that, and get that character. So we'll get Owen Carroll, and the length is going to go off. It's going to figure out what that is. I'm actually just going to play this. Stepping through it. So it's going to go off and figure out what that is. It'll return back the number of characters in that string, which is 12 characters. We're going to subtract 1 away from that to match our characters with our index referencing, which will give us 11. And then we're going to get the character at index 11, which if we start counting from 0, the last L will be index 11. Which will give us a lowercase l. And that gets printed out. Okay, so you can see what's happening there. It's going off. It's we'll count how many characters there are. And now go and find me that position in the array. So it goes off and it counts through it until it gets to that index in the array. A minute or thing, because we need it again. Okay, so that is our first or our second problem where we're using character at. Does that make sense? Is there any questions on that one before I move on to the next one? So with each of these questions, I'm going to iteratively make them more complicated. So this one here, if the user entered a string and we give them the first and the last character. The next question, we're going to use enter a string and a number, and we're going to find that character within the string, or sorry, that index within the string, and tell them what character that is. Any questions on that?
The first one gives us only the number because we didn't use the character.
So, sorry, when you say the first one, what do you mean the first one?
The first example you gave to us.
Oh,
when
right.
you put your name and it gives us.
It just gives us the length. Yeah, yeah. So I just wanted to see how many characters were in that string in total.
And when you add the character.
Here, yep.
Yeah, and that one gives us.
I'm pointing here at a position in that array or in that string, and it'll return back the character that's sitting in that position. Everyone else okay? Good. Okay. Good. Let's go 3. String 3 here. Going to take a string in from the user. Sorry. Yes.
In Joliet, when you compile it, does it actually compile it and saves that file somewhere?
It kind of holds it in a temporary. It doesn't compile. It doesn't compile. No, I would not use Joliet as your normal development environment. It's really only useful as illustration. So you can save the code in a specific location, which means it's not held in the temp file. But the way Joliet normally works is it saves the class file and then kind of tidies up after itself when it's finished.
Yeah.
Okay, so we're going to create a program that takes a string and a number in from the user and prints that character at that position. Okay. So I'm going to take in my string. I already have that. That's great. I need to also take in a number now. Let's enter a number. Okay. Don't need the last bit there. Okay. So I have added in that I take a number in from the user. Nothing new about that. We've done that before in code. But the new thing is here, I'm running the same command as in string 2 here. We can see on line 12. But rather than hard coding in a 0 in it, I'm using whatever value the user enters in, hoping that that value is within the boundaries of the string I've entered in. If I enter in my name, which has got 12 characters, I shouldn't enter in 45 as the number I want to print. That's going to cause a problem because it'll try to access an element of that string that does not exist. Okay, I have a feeling this is going to show me a weird error, which is good because I want to show you the weird error. So let's go and test that. And then Java. String. Please enter a string. There we go, Carol, it's fine. Enter a number. I'm going to enter in not 4 because that's a space. Remember that that's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'll enter 9. So if I enter in 9 here, it gives me lowercase o. If I run that again, and I enter in 5, it gives me uppercase C. If I run that again, on the same string, I enter in 4. It has given me space, but obviously there's no visible type for that. But there is a space character there. Okay, so how that code builds upon what we've done already is just allowing the user to dictate where we want to get the value. The fact that I've got a variable here, it could mean if I wanted to, I could say n++, and then I could have this again. Okay, so I could do that. So the first bit, that's what we've done already. They enter in a character or enter in a number. I find that position in the array or in the string. I return back that character, and then I increase that position by 1. So if I enter in 4, it gets 4 first, and then it goes off, prints out whatever index 4 is, and then we increase 4 to 5, and then I go off and I get 5, and I print that out as well. So if I were to run that, string, if I enter in 6, it'll give me A first, and then it gives me OR, which is the next number after that. Does that make sense to everybody? Any questions on that? Everyone's happy enough? Okay, so if you look at the 2 questions we've done, excuse me, sorry, initial view, strings 2. Okay, so if you look at these two questions here, in the one on this side here, I am taking in a string and I'm getting two fixed points in that string. I'm getting the first and the last position. The one on the right-hand side, I'm getting the user to enter in a value, so I put it into a variable, and I'm getting that position, and then I increment that variable by 1, and I get the next position. So combining both of these, what I'm going to do for the next question is I'm going to get the user to enter in a string, whatever it is, and we are going to go one by one through every character in that string by using a loop to automate the bits that I've done manually here. So we are going to create a loop that's going to start at index 0. It's going to move one by one through it by using our ++ command, and it's going to stop when it hits the last part of our string. The easiest thing to do here is, rather than printing out that string horizontally, we're going to print it vertically, so one character per line. That's the easiest way of illustrating this. Everyone clear on what I want to do? Yeah. Cool. Okay. Copy that. Here. Take string in from the user. Vertically. Is there two L's in vertically? Oh, today there isn't. Set that there. Okay, so strings 4, that's what we have here. Enter in a string, that's all I want there. I don't need this input because I'm not asking them to enter in a user input there. I'm going to create an int counter, 0. I'm going to have a while loop. That's going to say while counter is less than s.length. There we go. And inside that, I'm going to take this, and I need to edit that code slightly. I'm going to say char c is equal to character at whatever the value of counter is. So it'll start at 0, then go 1, then go 2, then go 3, and so on. Print out c, and then this should be counter ++, and I don't need these. So this block of code now, what it's going to do is it's going to ask the user to enter in a string. They're going to enter in the string of undeterminate size. We don't know how large that string is going to be. We're going to set up our counter variable to start at 0, and we're going to keep going while it's less than length. Okay, so like with the other loops that we've done, we want to go up to but not including whatever value this is. That's kind of the same as writing, well, it's less than or equal to length -1. But I'm not going to do that. That's a more common way of writing it. For every single character I come across, so as I move my window of focus through every character on that string, I'm going to extract the character at my current position. And remember, I'm going to have essentially like a marker. Here's position 0. Finish doing that here, move on to the next one. Move on to the next one, move on to the next one, move on to the next one. It'll work its way across. I'm going to take the character out, I'm going to put it into a new variable c. I'm going to print that going ln, so to print out one character and move on to the next line. And I'm going to increase the value of c or of counter by 1. So now what was 0 becomes 1. So I'm printing out the character at variable index 1. Move on to a new line, increase counter to 2, print it out at index 2, and repeat and repeat and repeat until I get to the end.
Why did you open another one in the line 14?
Line 14 here.
Yeah, but you open again.
Open this, because I need to say that all 3 lines of this here are part of that loop. So if this is true, if the value of counter is less than the length of the string, I want to do all 3 lines here. Okay, so let's have a look at this. Java C, what was that? That was strings 4. Java strings 4. Enter my string. I'll keep going with the same one I have. On Carol. I want to enter this. You can see that it prints it down the edge there, 1 character per line. Okay, once I can do it 1 character per line, I can mess around with that. I can change how many characters I want to print on each line. I can print it in a diagonal fashion. I could do something where it prints out something like that. But we're not going to get to do too much of that messing today. But what that does is it says, okay, get the first character, print it out, move on to a new line. Get the next character, print that out, move on to a new line. Get this next character, print that out, move on to a new line. And so it'll keep moving its way down. And when it hits the last character, it says, okay, you're now at the end of that string, stop. And that's what the guard in our code is going to do on string 4 there, is when we hit the end, when counter has a value that's equal to length, then we're not allowed into that loop anymore.
Could you show us the thing with having a space?
Oh, you want to do the diagonal?
Yeah.
Okay, all right, okay. That'll be part 5. Is everyone happy with this one here? Before we get fancier. Right. What is the bit that you would like me to go over?
It's about the line 15.
Line 15, this one here?
Yeah.
Yep. Okay, so what we're doing here is we're going to create a new variable character C, new variable C, which is a character data type. And because we created inside the curly brackets of our loop, it only exists while the loop is here. When we get down to line 18, it disappears. We recreate it again, and we do that for however many times we have in the loop. When we get down to line 19, we destroy it and we never recreate it. Okay? And every time we do that, we say go to the string, go to the character at whatever the value of counter will be. So counter starts at 0, then goes 1, then goes 2, then goes 3, then goes 4, which means that we're going to the first letter, the second letter, the third letter, one at a time as we're working our way through it. And it copies that character out and puts it into variable C, which allows us to print it here. And then we can increase our counter, which says, well, if I was here last time, move me to here. And it moves on in the string.
So when you move this, bring it down, why it doesn't bring it like?
Because I use print ln rather than print. So if I change that very quickly,
Yeah, of course.
just to that,
It will bring it down.
it's kind of redundant because it ends up printing it out horizontally, but 1 character at a time.
Yeah.
That's all it was, just by removing the ln there. Okay?
Yeah.
Everyone else happy enough with this question before we have to make it complicated? More complicated? Yeah? Okay. Copy. String 5. And complete. Okay, so we're going to print it out diagonally. When we are finished, our code looks, or our output should look, something like that. So let's have a look at what we want our output to be. We know how to print it 1 per line, so that's already been achieved. What we need to work out is how do I push each subsequent character out 1 further? Anyone have a guess on how we do that?
Counter for increments of 2.
If we had a counter for increment of 2 and we didn't change anything else in our code, it would skip every other letter.
Oh, yeah.
So our command, the print command, just prints the current character and then the plus plus moves on to the next character. So they kind of all remain the same. But look at, so here we have the character and nothing in front of it. Here we have the character and 1 space in front of it. Here we have the character and 2 spaces in front of it. Here we have the character and 3 spaces. Here we have the character and 4 spaces, and so on. So the change, the thing that's different between the previous example and between this, what we want to solve, is that we have a growing number of spaces to print before we print whatever character it may be. Okay? There are multiple ways of doing this. But I'm going to show you what I feel is the easiest way to do this. So if you go, and this is kind of a really common way of printing it, and then the nasty version is printed diagonal going that way, which I won't. But that is the nastier way of doing it. So the simplest way of doing it, I'm going to show you in a moment, but you will see as you look through it that people will have one loop to go down through the characters, and then they'll have another loop to go across through the lines. That makes things a little more complicated than we need to. Because when we start our program, we have a string of however many characters we have, and we know we start at the first one and we move our way along. So we have a reference point for what to print on any one line. We know that. We also know that the number of spaces on the first line is 0. There's nothing in front of that character. And then each subsequent line increases the number of spaces by 1. So what I'm going to do is I'm going to create a new string spaces, and that will start as an empty string. So if we look at this inside strings 5, I created my string S there, that's the user input. I have my counter here. I'm also going to create string spaces. It's equal to an empty string to begin with. And what I'm going to do is I'm going to add in an extra bit of my printout. So I'm going to print out spaces plus C. That's the first thing I do. The next thing I do is I'm going to increase how many spaces are inside this string. And then I'm going to increase my counter, which moves me on to the next letter. Which means the first time I run it, spaces is empty. So it's empty plus whatever the first letter of your string is. So it just prints the letter. I'm going to add 1 space in here, increase my counter. The next time I go around, I'm going to print 1 space and the current counter. And I'm going to increase the number of spaces by 1. The next time around, I print 2 spaces and the current counter. And I work my way through that. So how I would do that is I get my current character. That's fine. Leave that as it is. I'm going to say print out spaces plus C. That's the extra bit here. So we have to print the number of spaces. That's fine. This is the last line where I move my counter to the next letter in my string. But before I do that, I'm going to say spaces is equal to the current value of spaces, however many spaces we already have, plus 1 more. And because this line of code is going to run every time, it starts out empty, then 1, then 2, then 3, then 4, then 5. So we will slowly increase the size of our spaces variable. And all spaces string is a string of spaces. Does that make sense? So let me just double check it does what it's meant to do, and then I'll come back and we'll run it again. So Java C. Strings 5.java errors, that's always a good sign. Then Java strings 5. Enter my string, and it prints it out in a slanty fashion. Okay, so I'll go through that loop again, and then I will relate you to an exam question, which I think I asked last year. I can't remember, to be honest. I know I've asked it in some assessment somehow, so it's likely to come up again. I enter in the string, that's the exact same as last time. I have my counter set to 0, that's the exact same as last time. The new thing I've added in here is I start a string called spaces, which starts completely empty. There's nothing in there. I get my current character, it's the same as the last example. I'm going to print out whatever's inside my spaces string, which starts out as nothing, plus whatever character I've currently got. And then I'm going to add 1 space onto it. Remember that this, when we have a string and a string, this symbol in between it is concatenation. It just tacks on the right-hand side onto the end of the left-hand side. So we're kind of gluing them together. And then we're going to increase our counter, which will move it around, and we keep repeating that. And these two here, there's no variance in them. They're just going to grow and grow and grow, or move from the left-hand side to the right-hand side. The thing that changes is what counter or what character we're pointing at, which is our counter is moving around. Does that make sense in how I solved that? Yeah? Let me very quickly see if I can see if it was last year's exam paper I asked the question. Useful links. Exams. Confusion. Not 2014, or 15, or 16, or 17, 18. Might be here. Don't know. It's not in August, it would be in January. Okay, let me quickly just check here. It's on Moodle, we archive off the last couple of years worth of papers. You'll be able to see them. Obviously, you can go and look at the exam papers now, but we haven't covered all this content. No, that was a string command we used there. No, not in that one. Right. It's in that one. No, it's not in that one. Right. Is it diagonal difference? I don't think that's what's the problem. No, what a ridiculous website. There we go. Okay, this is not exactly it, but I got them to enter in a matrix. So we have a 3x3 example here. And the idea is to enter in one number, it would randomly generate this. And then what it would do, it would work out the diagonal going from left to right, and then the diagonal going from right to left. So it is possible that I would ask you a question that would involve you doing it more complicated, that you would start on the far side and work your way back. If I was to do that, huh?
It's a long test.
Well, I mean, again, remember, you're not getting a test on this until May. Your final exam isn't until May. So even if I was to ask something like that, you would be far more practiced before we get there. But let's wonder. Let's see if I was to print this out diagonally going the other way, and maybe I will just to show you it's not impossible. If I was to print it out diagonally the other way, so I would have H, E, L, L, O, and then this would be 1. Okay, so if I was to print it out that way, I basically go through the same thought process to work out how that happens. The bottom character is going to have no spaces in front of it, which means the second last is 1, third last is 2, and so on as we work our way back up. So the number of spaces here is going to be 1, 2, 3, 4. The string I've entered in is 5 characters. So the number of spaces I need, so that if I ran string.length, I would get 5 on the word hello. So the number of spaces I need before I print the first character is going to be length minus 1. That's the first thing. That's actually the most difficult part of this, is working out what that number should be. The next step you would need to do, and again, since we've just really looked at loops and strings, this mightn't be the most obvious, is that we would create a loop to build a string of however many spaces we need, length minus 1. And we save that. And then all we're doing is we're chopping off 1 space as we move our way down. So there are multiple ways of doing it. But if I was to do this, 5 I did. Yes, I did 5. So let's copy that. Let's put it in 6. Let's go up here, diagonally. Right. Ooh. Right to left. So I need this. I need to build my space string. So I need to, before I go into the loop to actually go through each character, I need some sort of a way of increasing the space string to whatever size it needs to be. So there are a couple of ways of doing this, but the reality is we don't know how big that string is going to be. We don't know how many characters the user is going to enter in. They could enter in 11 or 12 or 96, which is one of the ones I did, or 4,000 or 10 million. We don't know. So saying spaces is equal to and it's holding down like that might work for the example and might not work for the example. So that's not really the best way of doing it. What we really need to do is we need to create a while loop. Our counter is less than s dot length minus 1. And here we're just going to say spaces is equal to spaces plus space. Counter plus plus. So this loop here, from line 16 to line 19, it's going to go through the length of the string. It's going to be one less than what I normally do, because if you think about the first line, I've got a whole lot of spaces and one character. And that has to match up so that the very last line, I've got no spaces and the last character. And rather than doing anything with the actual values inside the string, I'm using that as a measuring tool. I go, oh no, add another space. Am I at the end yet? No, add another space. Am I at the end yet? No, add another space. And keep working my way down. And so at the end of this, spaces, the value for spaces will be a string of X number of spaces. That's the first thing. The second thing we need to do is we've changed the value of counter. We've changed it from 0 all the way up to length minus 1. So we need to reset it so that when we go back to this loop, we actually start at the first character and not kind of somewhere toward the end of our string. So what we need to do on line 20 is we need to say counter goes back to the value of 0. This is going to reset counter, reset. Now, what was left from the previous example, and since most of you seem to be okay with that, this loop stays the same. This command stays the same. This command stays the same. This command stays the same. The only thing I need to change is line 24, because line 24 grows my spaces. And what I want to do is I want to contract it. I want to remove elements off that. So, what you cannot do is that.
I was thinking of
That's
I know you were thinking of it, yes. You cannot do that. That will not work. I know it logically makes sense. Oh yeah, just take a space off. Take a space off. How do you take something off? Well, that's subtraction. Use minus. Yeah. It doesn't work like that, unfortunately. So I need a way of systematically reducing down my string, getting it smaller and smaller and smaller. The best way I think of doing it, the simplest way of doing it, is using our substring command. Remember, our substring command will take a string and give me a subsection of it. Not all of it, it'll remove a key amount, and we can define how much that'll be. So what I could do is I could say the new value of spaces is equal to the old value of spaces. I'll use a substring here, and I will give it, substring's got two really good commands. The first one is the one I have in the notes, where you give it a start point and an end point, and it chops out usually the middle. Not chops out, it doesn't chop anything out, it leaves the original string the same. It clones or replicates something in the middle. But it has another command where if I just give it one value, it goes from that index all the way to the end. So if I were to give it that, 1, it would start from index 1. In other words, it would ignore the first character, and it would start from index 1 and copy from that all the way to the end. So in my initial string, here, let's say I've got 11 characters in my string I put in. By the end of the first loop, by the time we get down to line 19, the variable spaces will have 10 spaces in it, going from index 0 to index 9. This command here would chop off the top. It would go from 1 to 9 and create that as a new string, which actually is 0 to 8. So we've gone from 9 as our last index to 8. The next time we go around, it will go from 1 to the end. So 1 to 8, which is actually 0 to 7. So now we've reduced it down 1 again. And that will keep moving down by 1 each time. Because the only thing we're doing is we're skipping the first. We're creating a substring, which is a replica of our string, except we've left off everything before the index number 1, which is the first index, just index 0. And that will reduce over time. That's my idea anyway. Hopefully it'll work. Let's test it and then I'll come back and go through it again. That's 6. Let's go CS. And Java C strings 6. Java strings 6. That's because I called it 5. There we are. Okay, enter a string. I'm going to enter in all again. Excellent. Now it looks, oh, right. Okay, so 2 things. I have an error down there. I'm going to talk about that in a moment. It does look weird. The characters are not backwards, but it kind of gives it's disconcerting looking at it going that way. But it does kind of what we want to do. However, look at this. We have an array index out of bounds, a string index out of bounds exception. This is a really common error when we're dealing with strings. What that means is you've tried to access a part of that string, an index of that string that does not exist. What I've tried to do is -1, which since we start our index at 0, makes sense. You couldn't possibly be accessing element -1. So I need to figure out, how do I do that? How do I get around that? And it's line 24 it's telling me is the problem. So let's have a look here. Line 24, of course, is this one here. Okay. So it works. Our output is this right all the way down, except for the very last time that I try to run it, where my counter is going to be equal to length -1. It has an empty string. There's nothing in that string. There are no index points at all, and it tries to access index that's beyond that, and that's where we're getting our weird substring there. So to help this, I need to have an if statement that says I will only do this when the string is larger than a certain amount of size. So what I have to say here is if spaces dot length is greater than or equal to 0, then I'm allowed to do this bit of code. Otherwise, I'm not. And what that should do is that should make sure that as I'm reducing down the size of my string, that I don't try disappearing into the negative index, which does not exist in any collection size. So it'll stop me when I get to the first index. So if I get to the first index, we can still increase counter, which will still go up here, it'll break this loop because counter is growing in size, but we'll never have tried to run this the last time, which will crash it out. So save that and just check if this is going to work. Compile, run, enter my string. So, excellent, another error, fantastic. Why is that happening? Index out of range, that substring, blah, 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 blah. Right.
So we're just saying I did just the same as you said before if mine worked.
You do the exact same and it worked? Show off. Right. Hang on. Cool. There, that's what it was. Right, okay. So, greater than 0. Because I keep forgetting that the last time we do it, we don't want to, the length of the string is going to be 1 less than the number of characters we have. Because if we've got 10 characters, the last line, the 10th character we're printing out in our user input, there should be no spaces in front of it. And that's why it got reduced down. So that's, for me, why it didn't work.
Can I just ask, if we get questions like that in the exam, how
Yeah.
does that work? Because if you make those kind of mistakes, you won't know.
So if I were to give you a question like that, because that's actually a really good point. If I were to give you a question like that in the examination, I would have certain things that I'd be looking for. So I would be checking, rather than checking every single line, if you got a quotation mark, if you spelled this with a capital A, because it's a handwritten examination, there are things that are kind of trivial because as soon as you put it on a computer, you'd immediately fix all that. So I would probably have a check for this. So there'd be a certain amount of marks going for this. There'd be a certain amount of marks going for how did you figure out how to do that. There'd be a certain amount of marks for doing the actual processing through the string. If you were, like I did the first time around, to put the equals in there, out of the 20 marks going for that question, you might lose 1 or 2. You would end up losing some because again, it's the questions have to be small enough. The normal large questions I give in an examination, I estimate the average student takes half an hour to solve. That's think about it and write it out. So if you make a typing error like that, you saw me there, I tested it, it didn't work, I changed 1 character, it worked. So I had the right idea, and just needed a little bit of refinement. So you will get a penalty, but not like 0. You're not going to fail the question on missing 1 single character. It's more your approach to the problem. How did you look at the problem and how did you break that down to different parts? Okay, and that's really what first year programming is about. You're doing systems analysis with Gemma, right, for part-time. So the whole point of systems analysis is here's what the client wants. They have a non-technical specification. I'm going to bring it up to a technical specification and then break it down into little parts, detailed enough that I can just give it to my programmer and they can build it. As the programmer, if you have that, that's fantastic, but we don't always have that. So I also need to be able to look at a reasonably well-defined problem, which is what I will give you in the exam, and be able to break it into smaller parts. And what I'm looking for you as the students who are taking these exams or class tests is how well can you solve that? How good is your approach to the problem? If you leave out a character here, or if you forget a bracket there, I mean, first of all, I'm human and I'm correcting pen and paper, so it's very possible you might have left the equals mark in or put the equals sign there. I missed it and gave you full marks. That's always the likelihood. But also, if you leave a semicolon off, or if you spell car at with all lowercase or the capital, I know for 99% of the time of that it's an exam pressure and handwriting combination. You're already in a pressured environment, and now you're writing it in an environment you're not used to. I'm very lenient on that type of stuff. If your approach to the problem, build up the string of spaces first, go through the characters 1 by 1 and slowly reduce down the string. If that's your approach, you're going to get 75+% of the marks for that. And where the remaining 25% are is like, again, little things like that where I might have explicit marked it. Or if I were to give you a question like this in a class test, I might be really nice and say, make sure you don't go off the range of the array or off the range of the string. So can I give you a prompt? Without telling you what the answer is, just say, by the way, look out for this. Fair enough?
Mm-hmm.
Does anyone have any questions on that? Does it make sense? Kinda? Yeah, okay, right. Well, you haven't had a chance to do anything yet. So I'm going to upload these 6 files onto the OneDrive, and I want you to do a question for me. And the question I want you to do is I want you to take in a string from the user and print it out backwards. Between the examples we've done today, plus the string or the loop examples we did before the break, you should have all of the information you need to do that. But let's see if we can do that one. So let me copy the stuff over to the OneDrive, and we'll take maybe 15 minutes to go through and see if you can print it out backwards, and then I'll go through a solution and we'll finish up 5-10 minutes through. Shut that down. Shut that down. No. OneDrive. Part-time. So there's no easy way for me to get around this in the OneDrive. I've been numbering the weeks as we've gone through it. Technically, because of assignment week, we are in week 9. To avoid confusion, I'm going to call it week 8, because otherwise someone will say, hang on, you missed a week. But also remember, then we're only going to get up to week 12, not week 13. So there's no way around. If I go one way, people will complain. If I go the other way, people will still complain. So they are all on the OneDrive now. It should mean that you can have access to those as well. Have you seen what the link is to OneDrive it is?
Yes.
Yeah, okay, got it.
Why is not stable? When it's I say in the desktop, it takes 2 items. But it's not saving straight to the load.
Okay, that's odd. Let me see if I can show you that here. Usually, this is a new machine, isn't it?
Yeah.
Yeah, so usually, it's just a case of, that should change it. Okay. That is really weird. So this is just a notification to your. Okay. More apps. PC. That is very, very odd. Now, the only thing I say is that is here. No, that's on your desk. That is, I do not know why that's happening. And that's quite unusual that that would do it that way.
Yeah. So choose.
Now, class, you wouldn't open a class file
Mine's
at all.
open 2 files.
So your Java files the code you write, but then when we run the Java C command, it builds the machine runnable code, which is your class file you just open up there. So the code we write is not usable by the computer, so it needs to be converted into something that is, and that's what the class file is. So if we build the code properly and we get the Java C command with no errors, well then it creates the class file for us.
Oh, okay, that's why it's class. Okay.
Yeah. No weird messages in this string.
You have to keep it safe, right?
Have you heard?
The class.
No, you don't.
Can
No. So if you delete the class file, that you can just run the Java C command and rebuild it for you. And every time you alter the code and you run Java C again, it overwrites and rebuilds that file. So it's not fine.
Yeah, we only.
Okay.
Camera.
Usually with OneDrive, you get a certain amount of months free, and then you get a terabyte.
Yeah, that's
Okay. Okay, that's very odd. I don't know. I don't pay for it. I pay for it. That's odd. But your Griffith College student account should give you nearly a terabyte of storage, and maybe that's three.
Yeah.
Yeah.
So we can send the assignments into the on
Correct, yeah.
26th.
Yeah.
Okay, good, thank you.
No problem. You're.
What did you? Oh, yeah.
Especially with a new machine though.
Yeah.
The class is the next one. You have to be.
All of this. Okay. Let's have a look at how we do this. So what we want to do is we want to take in a string from the user, and we just want to print it backwards. Now, I already kind of mentioned earlier on, I didn't want you to use the string.reverse command, which would just take that string, flip it backwards. So we are going to, we have our start bit of our code here. We take in the string from the user. So after line 10, we have the string inside our system, so we just can manipulate it then as we wish. And what I'm going to do is I'm going to create a loop. But rather than starting my loop at index 0, I'm going to start my loop at the last index in that string. And I'm going to decrement my counter, so move it back towards 0 as I go through the loop. So what that means is that I'm going to create my counter here. So int counter is going to be equal to s.length. Type it. No, that's not how you type it. There. It's not going to be s.length, because remember, s.length will give me, if I have 10 characters in the string, it'll give me 10, which is one bigger than all the index that I have. So I need to be, it needs to be s.length minus 1. So if I've got 10 characters, it gives me the 9th index, which is the last character in that string, excuse me. And then going to have a loop. So I'm going to say while counter is greater than or equal to 0, because I do want to go all the way down to 0, because that will be the first character in the string. And then the internals are almost the same. Char c is equal to s.char at counter. System dot out dot print. That's going to be print, not print ln, so print it all in one line. I'm going to print out c, and then counter minus. Okay, so as you can see, it's a pretty small solution to do that. The trick here is working out where do you start from. And most people, exactly as you mentioned about, well, it would have, if it was greater than or greater than equal to, where would you use the marks? Most people, if they were to write this out pen and paper, would forget the -1 there. They'd go string.length, and they'd be slightly off. To me, that's the right approach, with a trivial mistake that you would spot immediately once you put it into a digital format. So I usually wouldn't be tough on that one at all. Excuse me. If you start a counter at 0, well then it's a different question. So this will go to my length of the string. So however many characters in the string, -1, which means that I'm in the correct range of my indexes. And my counter is going to keep going while the value of counter is greater than or equal to 0. So it'll go all the way down to 0, and then when it hits -1, it breaks the loop. And for each time I'm in here, I get the counter or the character at my counter. So it'll be the last character, second last, third last, fourth last, fifth last, and works its way across. Print out that character, and then I decrease my counter variable. So it's moving it back towards 0. So let me test this. Save here. Not strings, that's not what I want. 7. And then if we go to Java, strings 7. String 7, hang on. Let's try that again. There we go. Save. It's been a long day, folks. Right, there we are. Enter a string. Okay, so enter a string, Owen. And when I press enter, then it prints it backwards. Okay. So the 7 programs that we looked at there are a good introduction to what you can do with strings, what type of manipulation you can do with strings, and how you might do those manipulations. Next week, we will do a little more work on strings. We will look at how we can manipulate those questions or manipulate those strings and the values in the strings, and how we can look at different types of evaluations. Next week, I will also have your first take-home large assignment. I haven't decided exactly what it was or what it's going to be yet, but it'll involve the first 5 elements of programming guaranteed, because you can't solve problems of any meaningful size without that. And in my head, I'm just working out, will I apply it to strings or not? If I apply it to strings, obviously I will do some useful examples next week. Next week, we're not doing anything new. So next week's lab, what it's going to be is I'm going to come in with basically a string worksheet, and we'll go with, I'll explain the problem. I'll give you 15, 20 minutes to work on it. I'll go through a solution, and we'll go back and forth that way. So there's no new notes for next week. There might be a very small bit on characters, but that's about it. It'll be more just kind of what the latter half of today's class was. Fair enough?
Okay.
So if you have questions or bits that you're not 100% on those first 5 elements of programming or on what we covered in strings today, bringing them to next week's class is ideal, because it means as I'm going through the examples, I can highlight bits to clarify. Okay, thanks a lot, folks. I will see you next week. Stay home.